Hello everyone, hope all of you are doing great. And in today's video, we are going to discuss lesson 13.1, which is all about bearing. The first question here that we're going to discuss from the workbook is actually question 4. It says to you that Luca and Fabia stand by a gate. Luca walks on a bearing of 230 degrees for 200 meters, while Fabia walks on a bearing of 280 degrees for 300 meters. Copy and complete the scale drawing to show their journeys. Use a scale of 1 centimeter represents 100 meters. So the most important step that I really need to start with is the scale. They told you here that 1 centimeter is actually 100 meters. We're going to need this. Okay, I'm going to get this. Or you can even start, if you're going to copy it, you can just start it in your own copybook. And the gate is the start, okay? So here is the gate. I'm gonna need to draw the north as we agreed, and this is your first step. Start with drawing north. Here we go. North. Label it N. Done. Okay. Let's now start answering the question or drawing the diagram. Luca and Fabia stand by a gate. Done. I drew already the gate, the start point. Luca walks on a bearing of 230 degrees. We agreed that we started the bearing clockwise. Bearing is what? Clockwise. Mister, we need 280 degrees clockwise. This is not possible. My protractor doesn't show more than 180 degrees. So here is the protractor. It doesn't show more than 180 degrees. Yes, but we agreed on a solution to this. What is the solution? We agreed that we're going to minus 280, 230 from 360. So it is 360 minus 230, which is going to show us 130 degrees. But instead of clockwise, we're going to do it anti-clockwise. So I can draw a 130 degrees anti-clockwise. I'm going to put the center of the protractor at the angle that we have over here, which is G. Done. And after that, what are we going to do? I'm going to find 130 degrees, but anti-clockwise as we agreed. So 130 degrees anti-clockwise. I'm going to start from the zero that I put already on the side, which is this zero, the one that is inside, until 130 degrees, which is this one. You don't need to draw the arrow actually. All what you need is just a point, but I'm using the arrow for technical reasons with the protractor that I have here on this application. So I'm gonna remove this right now, and as we agreed, all what you need is just a point. That's it. This determines the direction of Luca, the way Luca is going to walk. I'm gonna remove the protractor for now, or let's leave it because we're gonna need it. Uh, Here, I'm gonna just do what? This is my direction. They told you for 200 meters. 1 centimeter is 100 meters, so all I need is 2 centimeters. 200 meters are actually going to be represented through 2 centimeters only. So I'm gonna get my lovely ruler and I will start here, this direction, only 2 centimeters, only 2 centimeters, but this direction, you see? So the point or the bearing that we've just found earlier, is only for determining the direction. But for how long? No, that's the distance. They told you 200 meters, which is only 2 centimeters. So I'm gonna draw here a line from the start point, which is the gate, only 2 centimeters. Stop. That's it? Yes, that's it. Good. All right, let's continue. I don't need any of this. None of this is needed. And even this arrow here is not needed. Let's continue. Fabia walks on a bearing, so Fabia is also still at the gate. But she's going to walk on a bearing of what? 280 degrees. We're going to do what? 360 minus 280. Why, mister? Because I cannot get 280. It's 280 clockwise. So you're going to find out that it is 80 degrees anti-clockwise. So I'm going to get the protractor again, put it on the same, which is the gate, uh, starting exactly like Luca, but this time it is only 80 degrees. Here is the zero that we're using until 80 degrees is here. So until 80 degrees, which is this one. Okay, you don't need to draw the arrow. I'm just drawing it for technical reasons with my protractor. So here is the 80 degrees, this direction. I'm gonna erase all of that once I finish drawing the line. For how many meters? They said for 300 meters. The 300 meters, which is going to be only 3 centimeters. So only 3 centimeters with my ruler in the same, in this direction. See, I'm gonna do that. Here you go. This is the direction I need to follow. But how many meters we agreed? We agreed only 3 centimeters. Here we go. 3 centimeters. Good. So what we can do right now is what? Is just we finished actually, but all what you need to do is just labeling that this is Luca and this is who? What are the name? Fabia. Now we drew the diagram, but they are requesting from you, what are they requesting? Complete the skill drawing to show their journeys. That's it. خلاص كده we completed the diagram to show their journeys. You don't need any of the other stuff over here. It is only this one. No arrows, you cannot extend it. This must be only 3 centimeters. This must be only 2 centimeters. Dom and Carrie stand by a gate. Again? Yes, a gate again. All of them stand by gates. So here is the gate, G. Dom cycled on a bearing of 85 degrees. Aha, now it's got to be 85, not more than 180. So we're not going to need the anti-clockwise. So 85 degrees. So the first thing I need to do, Mister, is to draw north. Draw north up. Here you go. And I'm going to label it with N. 85 degrees, so I'm going to get the protractor. Here is the protractor. And I'm going to take it, put it on the center. This way, exactly. And then 80 degrees is actually here. Here is the 80 degrees. So remove the protractor, put it away for now. 80 degrees here. All right, for how long? Let's see. Carrie cycled on a bearing, once I Dom cycled on a bearing for 80 meters. So what is the scale? They told you the scale is 1 centimeter is equal to 10 meters. And he cycled for how long? 80 meters. So I need how many? I need a miss this direction, only 8 centimeters. Only 8 centimeters. So I'm gonna get the ruler and draw 8. This direction. I'm gonna need to remove everything. You're not gonna suffer from the with this arrow actually like me. You're not gonna suffer from it. I'm just using the arrow only because for a technical reason, as I mentioned earlier. So 8 centimeters is stop here, yeah, mister. And this is the bearing. Carry cycles on a bearing of now. Carry cycles on a bearing of 145 degrees. 145. I'm gonna get the same protractor, put it over here. 145 is actually there. Here you go. 145. Good. But for how long? They said 60 meters, which means I need 6 centimeters. So I'm gonna go this direction. This direction, I'm gonna go 6 centimeters. Here is my direction. And I'm gonna draw only 6 centimeters. 5.9 is not going to be a big deal. Fine. So 6 centimeters is here. Now I must show both their journeys on the same scale drawing. Done. Use a scale of 1 centimeter represents 10 meters. Done. On your scale drawing, measure the distance between Dom and Carrie at the end of their cycle. How far apart are they in real life? Yani don't go and say, for example, 7 centimeters. No, see, 7 centimeters is actually how many meters in real life. Okay, so we found that here is Dom and here is Carrie. So Dom and Carrie is here. So we need to know the distance. I'm gonna get the ruler. Just a second. Struggling a little bit with this ruler. Here you go. We need to know the distance. It is 7.5 exactly, mister. 7.5. 7.5 centimeters. So shall I draw the line? You don't actually need to draw the line, but even if you draw the line, it's not going to be a problem. Fine. So you're going to find that it is exactly 7.5 centimeters. But mister, does this answer my question? No, this does not answer the question because they want it in real life. So I'm going to say 7.5. Why is the dot not? 7.5 multiplied by 10 equals 75 meters. This is in real life. Question 6. A red Jeep is 50 kilometers east. What is the meaning of east? Here is the east. I know for sure that you know the meaning of east. Here is the west. Here is north. Here is south. So a red Jeep is 50 kilometers east of a blue Jeep, which means what? Which means that the red is here. A red Jeep is east, which means that the blue is here, and the red is east of the blue. Okay. The red Jeep travels on, but they said it is 50. I'm just drawing now, just a draft. So let's say that this over here, this saying that this is 50. So we got red is east of blue, but they said 50 kilometers. This is just a draft. The red Jeep travels on a bearing of 295 degrees. The blue Jeep travels on a bearing of 107 degrees. Could the Jeeps meet? Explain your answer. Type. Let's start from here. First thing, if you have this draft, they're not giving you any scales, so they're not requesting from you to draw scale drawing. They don't need scale drawing, okay? All what we need is just to see if they can meet or not. Can they meet? Could the Jeeps meet or not? The blue emitter is here, and the red is here. If I make the drawing over here of north, and here also north, for the bearing, north, north. Good. And they told you that the red Jeep travels on a bearing of 295. 295, mister, that is 6295. I'm gonna minus it from 360. This is a 9. That's going to give me, mister, 65 degrees. So this shows that the red is gonna go 65 anti-clockwise. 65 anti-clockwise. Look at this. Here you go. Here is the 65. I'm gonna need to remove the arrow. 65 anti-clockwise. So it is going in this direction, right? For how long? We don't know, and we're not actually interested. They don't want you to draw scale diagram. They don't want a scale drawing. So it doesn't matter actually how long, but just this direction, okay? So it is going to travel this direction. For how long? We don't actually know. All right, let's continue. Next, they're telling you the blue Jeep travels on a bearing of 107. Look at that, 107. I'm going to get the protractor and do 107. 107 is actually this direction. Look at that. It is almost here. So I'm going to go this direction. Here you go. For how long? We don't know, and we're not interested. Will the Jeeps ever meet? Are the Jeeps, so let me erase this, all right? Will the Jeeps ever meet? Look at the red and where it's going. Look at the blue and where it's going. Will they ever meet? No, yeah, mister. Never. Why? They go or they move in two opposite directions. One takes what? Takes the northwest direction, and the other takes the southeast. Look, one is going in this direction, and the other is going in that direction. Will they ever meet? No, they will never meet. Okay? All right. Let's continue. The next question. Two lighthouses are 120 kilometers apart. Lighthouse C is south of Lighthouse B. Let's see. South, we agreed it means like below it on the paper. Okay, so, or under it on the paper. So I got here, they are 120 kilometers. Where is the scale? The scale is what? They told you 1,500,000, and they want here kilometers. So they're telling you that one is actually 1,500,000, which means what, Mr.? Which means 1 centimeter is 1,500,000 centimeters as well. So if I want 1 centimeter is equal to how many kilometers? We agreed divide by 100,000. So by. This is how we divide by. So 1 centimeter is actually going to be 15 kilometers. 1 centimeter is 15 kilometers. يعني مثلا 120 kilometers divided by 15, it is going to give you exactly 1 second. That is going to give you 8, right? Yes, this is going to give you exactly 8 centimeters. And where's the other? Do we have another? No, we don't have another one. So let's start here. Two lighthouses are 120 kilometers apart. The lighthouse C is south of lighthouse B. So that means in B is at the top, and C is right below it, south. Here you go. Here is lighthouse C. It is south of lighthouse B. Okay, a ship is on a bearing, but they said for how long? For 120 kilometers, which we agreed that it's going to be what? 8 centimeters. We found that 120 divided by 15 is going to give you exactly 8. So I'm going to draw a line to show this. This is from 0 until 8. So it is here. C is supposed to be here. Now, this is 8 centimeters. From B to C now is 8 centimeters. Let's see if we're going to need to connect them or not. We're going to see now. A ship is on a bearing of 305 degrees from lighthouse C. All right, so I'm going to draw north from lighthouse C, and I will measure the bearing 305 degrees and the 200 degrees from lighthouse B. So I'm going to need to draw north from B and draw the bearing of 210 degrees. Let's do this. So here is the north from C. Do I need to connect them? It is totally up to you. For now, it is totally up to you. So N, and here they said bearing 305 degrees, which is going to be 360 minus 305 is going to give you exactly 55 degrees. So I must have 55 degrees anti-clockwise. 55 degrees anti-clockwise. I'm going to get my protractor. Here you go. The center. And then I go switch it anti-clockwise. Here we go. They said it is 355 degrees, we agreed. So 55 degrees anti-clockwise is going to be here. For how long? They didn't actually say. They didn't actually say for how long. So I'm going to erase the arrow. I don't need it. I just need the point. They didn't actually say for how long. So I'm going to just connect it and go this direction. Here we go. They didn't say for how long. All right, so the only distance that we have is this one, and it is said that it is 120 kilometers, which is 8 centimeters. All right, let's continue. They said also from light and 210 from lighthouse B. So I'm going to go to B and draw north from B. Here you go. North from B. 210, which means what? 360 minus 210 is going to give you exactly 150 degrees anti-clockwise. So I'm going to take my protractor and see about the 250. Second to put it in the center exactly. That's it. I guess I need this to go a little bit this direction. That's it. Okay, we agreed 150 degrees. Where is 150 degrees? 0. 150 is here. Here is the 150 degrees. But I'm going to do what? I'm going to put the point and erase this arrow. I don't need the arrow. I'm doing it only for technical reasons with my protractor on the computer. Now I'm going to connect this. For how long? They didn't say for how long. So I'm going to just connect it this way. It's just the direction. The direction is this way. I'm only determining the direction of the ship. All right, good. A ship. All right, now what is next? Draw the skill diagram. Done. What else is there? They're saying the captain of the ship thinks he is closer to C than B. So is he closer to C? Where's the ship? What is this point of intersection actually? This point of intersection is just to the ship. This is the ship. So the captain is saying that he's closer to C than B. Is he correct? Justify your answer. All what you need is just a ruler. Definitely by sight, we all can tell that yes, he is correct. Definitely. But if you want to measure it, all what you need is just the ruler, and you measure this part, and you say, well, let's look at this here. He's almost to 4 centimeters. 4 centimeters, so let's say almost 4 times, we said 15. 1 centimeter is 15. So almost 4 centimeters by 15 kilometers, which is 60 kilometers from C, while from B, almost 6.5. All right, almost 6.5 centimeters, which is times 15 kilometers. 1 centimeter is 15, is going to give you, this is going to be 90 and 7.5, 97.5 kilometers from B. So, yes, he is correct. That's the answer to question B. Now we drew the diagram and we've answered the question B. Please make sure that you watch this question, watch the explanation more than once if this is confusing to you, and most probably it is going to be confusing to you. Watch it more than once if you didn't get it completely from the first time. You might feel that you didn't get anything, but actually you got maybe like 40, 50% of it. If you watch it for the second time, you're going to most probably reach the 100% that you're seeking. And if you're still struggling, definitely bring it to me tomorrow in the class. All right, question 8. And I guess this is the last question. Yes. A ship leaves a harbor and sails 125 kilometers on a bearing of 80 degrees. The ship then sails 85 kilometers on a bearing of 145 degrees. What is the scale? We need to know the scale. They're telling you that 1 centimeter is actually 10 kilometers. So the 125 kilometers over here is actually what? 12.5 centimeters. This is 12.5 centimeters. And this one is 8.5 centimeters. And here we've got nothing else. So let's start drawing. A ship leaves a harbor, so we need the starting point, which is the harbor. H. North. Here you go. This is north. And they said what? What is the bearing? Bearing is 80 degrees. So I'm going to get my protractor. We need it clockwise this time, not anti-clockwise. It's not more than 180. So clockwise, 80 degrees. 80 degrees clockwise, which is this one over here. This is the direction where the ship will go. I'm gonna just erase my arrow. I don't need it. Now I'm gonna need to use, oh, sorry. I'm gonna need to use my ruler. For how many centimeters? We agreed it is 85 kilometers, which is 8.5. So it is for 8.5. I'm gonna need to go down a little bit. 8.5. Let's draw this direction. 8.5 is here. Well, that 1 millimeter doesn't actually matter. I'm gonna try to fix it once more. That's it, I guess. Yes, that's it. Okay, next. I finished now the bearing of 80 degrees, but they said actually this is the one. I'm sorry, it is 125 kilometers. So it is 12.5. 12.5, not 8.5. 12.5. Here you go. Here is the 12.5 on a bearing of 80 degrees. Done. Good. Next, the ship then sails 85 kilometers on a bearing of 145 degrees. So 1 second, mister. We're going to need to draw north because they said then, which means that from the new point, you go north from the new point. Here you go. North. But they said the bearing is what? 145 degrees. So I'm going to need my protractor. 145 degrees. Let's see about this here. 145 is going to be actually this direction. Facing a bit of a problem. Yes, here you go. 100, we said 45. So it is this direction. The point is going to be here. I'm drawing this arrow only because of technical issues that I have with the protractor on the PC. You don't need to draw this arrow, just the point is enough. So the point is actually going to be here. This is the direction I need to follow. Erase my arrow. All right. So for how long? We said 8.5. So I'm going to get my ruler. For 8.5. Gonna go from here. Why we need to follow this direction through the point 8.5. Here you go. 8.5 is here. Good. Now I finished this. Make a scale drawing of the ship, the ship's journey. Done. We agreed this is 145 degrees. How far must the ship now sail in a straight line to return to the harbor? In a straight line to return to the harbor, we're gonna need a ruler. And the ruler over here, we're gonna go this direction. And I start measuring to return to the harbor. This is what we need. Look at that. It is almost 18 centimeters. 18 centimeters. So how far must the ship now sail in a straight line to return to the harbor? It is 18 centimeters. But mister, we're gonna multiply by 10. So it's going to sail for 180 kilometers. On what bearing? So I'm gonna need to do this. Draw the line to see the bearing, because I'm going to need actually to do north to see the bearing. North from here. Here you go. And then I need to measure the angle. Let's see about this. Here we go. I need to fix it a little bit. Let me fix it first before I go down. Here we go. On what bearing you're gonna find, hopefully I'm putting it on the vertex accurately. You're gonna find that this is exactly from 0 until like 72 degrees. I guess it is 70. I guess this is 70 degrees. This is just a 70 degrees, this one. But mister, this is not the bearing. But let's just say that it is 70. Hopefully that it is 70. This is 70 degrees, but the bearing, mister, is clockwise. Yani clockwise. Clockwise, yani the one that is in there. This one. So the bearing is actually going to be what? You're going to find that it is 290 degrees. That's if we are accurate. It is around 290 degrees. Please, guys, watch the explanation more than once. This is going to help you a lot to understand the lesson better. If you have any questions, if still even after watching the video more than once or after watching the explanation of the questions you're struggling with more than once, uh, return to me in class and we're gonna have time tomorrow to discuss it. Thank you so much and see you in another video.